Electrical specifications for mining encompass several critical areas, ensuring safe and efficient operation within the challenging environment of a mine. This specification can be broken down into multiple sections, each addressing a key aspect of the electrical system. The first section typically covers general aspects such as the scope of the specification, providing clear definitions of terms used throughout the document. It also references applicable codes and standards such as the National Electrical Code, Institute of Electrical and Electronics Engineers Standards, Mining Safety and Health Administration Regulations, International Electrotechnical Commission Standards, and American National Standards Institute Standards. This section will also outline specific project requirements that the electrical installation must meet. The second section delves into the electrical system itself, including power distribution networks responsible for delivering electricity throughout the mine. This involves considerations for voltage levels, conductor sizing, and protection devices. Grounding and lightning protection are crucial for safety, minimizing the risk of electrical shock and equipment damage. Surge protection is also vital to safeguard sensitive electronic equipment from voltage spikes. Transformers are used to step down voltage levels for various applications, while switchgear provides a means of controlling and protecting electrical circuits. Circuit breakers and fuses act as overcurrent protection devices, interrupting the flow of electricity in the event of a fault. Conduits and cables provide pathways for electrical conductors, ensuring their physical protection. Proper lighting is essential for visibility and safety, while ventilation and dust control systems are necessary to maintain a safe and healthy working environment. The third section focuses on the electrical equipment used in the mine, including motors that power various machinery, pumps for geotouring, fans for ventilation, conveyors for material transport, crushers for breaking down ore, and loaders for moving materials. Each type of equipment has specific electrical requirements that must be considered during installation and operation. The fourth section addresses safety, a paramount concern in any mining operation. Electrical shock prevention measures are critical to protect workers from hazardous voltages. Arc flash prevention strategies are necessary to mitigate the risk of dangerous arc flash events. Fire detection and suppression systems are essential for early detection and control of fires. Emergency lighting provides illumination during power outages, while communication systems allow for effective communication between personnel. The fifth section outlines maintenance procedures, including regular inspection and testing to identify potential problems. Preventive maintenance helps to extend the life of equipment and prevent unexpected failures. Troubleshooting techniques are used to diagnose and resolve electrical issues. Repair and replacement procedures ensure that damage to worn components are promptly addressed. The sixth section considers environmental considerations such as dust and moisture mitigation strategies to protect electrical equipment from the harsh mine environment. Ventilation requirements ensure adequate air circulation, while noise control measures minimize noise pollution. The seventh section focuses on documentation, including drawings that depict the electrical system layout, design calculations that demonstrate the system's adequacy, installation instructions that guide the installation process, inspection and testing reports that verify the system's integrity, and maintenance logs that track maintenance activities. When selecting cables and conductors, several factors must be considered to ensure they are suitable for the specific mining environment. Firstly, consider the ampacity of the conductors, which is their current carrying capacity. This must be sufficient to handle the expected load without overheating. IEC Table 310.15 provides guidance on ampacity ratings for various conductor types and installation conditions. Secondly, the voltage rating of the cables must be adequate for the system voltage. Cables should be selected with a voltage rating that is equal to or greater than the maximum voltage they will be subjected to. Thirdly, the type of insulation must be appropriate for the environmental conditions. In mining applications, cables are often exposed to moisture, chemicals, and abrasion, so insulation materials like cross-linked polyethylene or ethylene propylene rubber are commonly used for their resistance to these factors. Fourthly, grounding conductors are essential for safety, providing a low impedance path for fault currents to return to the source. The size of the grounding conductor must be in accordance with the NEC Table 250.122, which is based on the size of the ungrounded conductors. Fifthly, cable shielding may be necessary in some applications to reduce electromagnetic interference. Shielded cables help to prevent noise from affecting sensitive electronic equipment. Sixthly, consider the mechanical protection requirements. Cables in mining environments are often subject to physical stress, so they should be protected by conduit or other means. The NEC provides guidance on cable protection requirements in Article 300. Seventhly, for portable cables, flexibility and durability are important considerations. Portable cables should be designed to withstand repeated bending and flexing without damage. Eighthly, fire resistance is another important factor, especially in underground mines. Fire-resistant cables can help to slow the spread of fire and provide more time for evacuation. Ninthly, consider the ambient temperature in the mine. High ambient temperatures can reduce the ampacity of cables, so it may be necessary to select cables with a higher temperature rating. Tenthly, compliance with mining regulations such as those from MSHA is essential. MSHA has specific requirements for electrical equipment and installations in mines, including cable selection. Grounding and bonding are critical for electrical safety in mining environments, and several key principles should be followed. Firstly, establish a low-impedance ground path. The grounding system should provide a low-impedance path for fault currents to return to the source, minimizing the voltage rise during a fault. Secondly, bond all metal enclosures. All metal enclosures, such as equipment housings, conduit, and junction boxes, should be bonded together and connected to the grounding system. Thirdly, use a grounding electrode system. The grounding system should include a grounding electrode system, such as ground rods, ground plates, or underground metallic water pipes. The grounding electrode system should have a low resistance to earth. Fourthly, size grounding conductors properly. Grounding conductors should be sized in accordance with NEC Table 250.122, which is based on the size of the ungrounded conductors. Fifthly, use equipotential bonding. Equipotential bonding involves connecting all metal objects in an area to the same ground potential, reducing the risk of voltage differences that could cause electric shock. Sixthly, inspect grounding connections regularly. Grounding connections should be inspected regularly to ensure they are tight and free from corrosion. Seventhly, avoid ground loops. Ground loops can create circulating currents that can interfere with electronic equipment and create a shock hazard. Ground loops can be avoided by using a single-point grounding system. Eighthly, use isolated grounding systems where necessary. In some cases, it may be necessary to use isolated grounding systems to protect sensitive electronic equipment from noise. Ninthly, comply with mining regulations. MSHA has specific requirements for grounding and bonding in mines, which must be followed. Tenthly, document the grounding system. The grounding system should be documented in detail, including the location of grounding electrodes, the size of grounding conductors, and the bonding connections. Effective strategies for preventing electrical hazards include several important measures. Firstly, implement a lockout-tagout program. A lockout-tagout program ensures that electrical equipment is de-energized before any work is performed on it. Secondly, use ground fault circuit interrupters or ground fault protection. Ground fault circuit interrupters and ground fault protection devices can detect small leakage currents and interrupt the circuit, preventing electrical shock. Thirdly, provide electrical safety training. All personnel who work with or around electrical equipment should receive comprehensive electrical safety training. Fourthly, conduct regular inspections. Regular inspections of electrical equipment and installations can help to identify potential hazards before they cause an accident. Fifthly, use personal protective equipment. Personal protective equipment such as insulated gloves, safety glasses, and arc flash suits can protect workers from electrical hazards. Sixthly, maintain safe work distances. Maintain safe work distances from energized electrical equipment to avoid accidental contact. Seventhly, use insulated tools. Use insulated tools when working on or near energized electrical equipment. Eighthly, follow safe work practices. Follow safe work practices such as keeping work areas clean and dry and avoiding the use of extension cords. Ninthly, comply with electrical codes and standards. Comply with all applicable electrical codes and standards such as the NEC and MSHA regulations. Tenthly, investigate all electrical incidents. All electrical incidents, including near misses, should be investigated to determine the cause and prevent future occurrences. Arc flash hazards are a serious concern in electrical systems, and mitigation strategies are essential for safety. Firstly, conduct an arc flash hazard analysis. An arc flash hazard analysis should be conducted to determine the potential arc flash hazards in the electrical system. Secondly, use arc flash rated equipment. Arc flash rated equipment is designed to withstand the effects of an arc flash, protecting workers from injury. Thirdly, implement arc flash boundaries. Arc flash boundaries are established to define the distances at which workers are at risk of injury from an arc flash. Fourthly, wear appropriate personal protective equipment. Workers who are within the arc flash boundary must wear appropriate personal protective equipment, such as arc flash suits, gloves, and face shields. Fifthly, reduce the incident energy. The incident energy of an arc flash can be reduced by using current-limiting devices such as fuses and circuit breakers. Sixthly, use remote racking systems. Remote racking systems allow workers to operate circuit breakers from a safe distance, reducing the risk of exposure to an arc flash. Seventhly, implement arc flash detection systems. Arc flash detection systems can detect an arc flash and quickly de-energize the circuit, minimizing the damage and injury. Eighthly, provide arc flash training. Workers should receive comprehensive arc flash training to understand the hazards and how to protect themselves. Ninthly, maintain electrical equipment. Regular maintenance of electrical equipment can help to prevent arc flashes. Tenthly, comply with arc flash standards. Comply with all applicable arc flash standards such as National Fire Protection Association 70E. Dust and moisture control are essential for maintaining the reliability and safety of electrical equipment in mining environments. Firstly, use enclosures rated for the environment. Electrical equipment should be housed in enclosures that are rated to protect against dust and moisture. National Electrical Manufacturers Association ratings such as NEMA 4 or NEMA 4X provide protection against these elements. Secondly, implement dust collection systems. Dust collection systems can remove dust from the air, preventing it from accumulating on electrical equipment. Thirdly, use moisture control measures. Moisture control measures such as dehumidifiers and condensation drains can help to prevent moisture from entering electrical enclosures. Fourthly, apply conformal coatings. Conformal coatings can be applied to circuit boards and other electronic components to protect them from dust and moisture. Fifthly, use sealed connectors. Sealed connectors can prevent dust and moisture from entering electrical connections. Sixthly, provide adequate ventilation. Adequate ventilation can help to remove heat and moisture from electrical enclosures. Seventhly, inspect equipment regularly. Electrical equipment should be inspected regularly for signs of dust and moisture ingress. Eighthly, clean equipment regularly. Electrical equipment should be cleaned regularly to remove dust and moisture buildup. Ninthly, use hydrophobic coatings. Hydrophobic coatings can be applied to electrical equipment to repel water. Tenthly, comply with mining regulations. MSHA has specific requirements for dust and moisture control in mines which must be followed. Proper ventilation and cooling are critical for electrical equipment in mining environments to prevent overheating and ensure reliable operation. Firstly, provide adequate airflow. Electrical equipment should be installed in locations that provide adequate airflow. Secondly, use fans and blowers. Fans and blowers can be used to increase airflow and remove heat from electrical enclosures. Thirdly, install cooling systems. Cooling systems such as air conditioners and heat exchangers can be used to maintain a constant temperature inside electrical enclosures. Fourthly, use heat sinks. Heat sinks can be attached to electronic components to dissipate heat. Fifthly, select equipment with appropriate temperature ratings. Electrical equipment should be selected with temperature ratings that are appropriate for the ambient temperature in the mine. Sixthly, monitor equipment temperature. The temperature of electrical equipment should be monitored regularly to ensure that it is within safe limits. Seventhly, maintain ventilation systems. Ventilation systems should be maintained regularly to ensure that they are operating efficiently. Eighthly, avoid obstructions. Avoid obstructing airflow around electrical equipment. Ninthly, use thermal insulation. Thermal insulation can be used to reduce heat transfer from the environment to electrical equipment. Tenthly, comply with mining regulations. MSHA has specific requirements for ventilation and cooling in mines, which must be followed. Regular inspection and testing are essential for maintaining the safety and reliability of electrical systems in mining environments. Firstly, conduct visual inspections. Visual inspections should be conducted regularly to identify any obvious signs of damage or wear. Secondly, perform insulation resistance testing. Insulation resistance testing can be used to detect insulation breakdown, which can lead to electrical shock or equipment failure. Thirdly, conduct ground resistance testing. Ground resistance testing can be used to verify the integrity of the grounding system. Fourthly, perform continuity testing. Continuity testing can be used to verify that electrical connections are secure. Fifthly, conduct voltage and current measurements. Voltage and current measurements can be used to verify that the electrical system is operating within its design parameters. Sixthly, perform power quality analysis. Power quality analysis can be used to identify power quality problems such as voltage sags, swells, and harmonics. Seventhly, test protective devices. Protective devices, such as circuit breakers and fuses, should be tested regularly to ensure that they are operating properly. Eighthly, calibrate test equipment. Test equipment should be calibrated regularly to ensure that it is accurate. Ninthly, document inspection and testing results. Inspection and testing results should be documented in detail. Tenthly, comply with mining regulations. MSHA has specific requirements for inspection and testing in mines, which must be followed. Maintenance and repair procedures should be implemented to ensure the long-term reliability and safety of electrical equipment. Firstly, establish a preventive maintenance schedule. A preventive maintenance schedule should be established to ensure that electrical equipment is regularly inspected and maintained. Secondly, use qualified personnel. Maintenance and repair work should be performed by qualified personnel who have the necessary training and experience. Thirdly, follow safe work practices. Safe work practices should be followed when performing maintenance and repair work, such as de-energizing equipment and using personal protective equipment. Fourthly, use appropriate tools and equipment. Appropriate tools and equipment should be used for maintenance and repair work. Fifthly, replace worn or damaged parts. Worn or damaged parts should be replaced promptly. Sixthly, lubricate moving parts. Moving parts should be lubricated regularly to reduce friction and wear. Seventhly, clean equipment regularly. Electrical equipment should be cleaned regularly to remove dust and dirt. Eighthly, tighten connections. Electrical connections should be tightened regularly to prevent loose connections. Ninthly, document maintenance and repair work. Maintenance and repair work should be documented in detail. Tenthly, comply with mining regulations. MSHA has specific requirements for maintenance and repair in mines, which must be followed.